Welcome to the Association of Fish and Wildlife Agencies North American Trapper Education Course video series. In today's video, we're going to talk about the components that make up a cable restraint and how it works. Always check state and local trapping regulations before setting any type of capture device. Cable restraints are a very humane tool to capture animals, but may not be allowed in your state. Read your local regulations carefully and consult with a local conservation officer if you have any questions. We also encourage you to select devices that meet best management practices standards. Let's start by discussing the cable itself. Cable restraints use galvanized aircraft cable, also known as GAC. This cable is made up of several strands of individual steel wire, which is wound together to create the cable. Most common designs are referred to as the 7x7 GAC or the 1x19 GAC. Now let's see how these cables are built. For 7x7, 7 individual strands of steel wire are wound together in a bundle. 7 bundles are wound together to complete the cable, hence 7x7, a total of 49 individual steel wires. When used for cable restraints, the two recommended diameters are 3/32 and 1/8 inch. For 1x19, 19 individual strands of steel wire are wound together to complete the cable, hence 1x19. All multiple strand cable are wound with a great deal of pressure applied to the strands. That pressure allows for the strands to stay together as cable. While cable is extremely strong, it is also very delicate. Cable lays in a certain direction because it was made and placed on a spool that way. Any bending opposite to the lay, kinking, or crushed wire strands renders the cable useless. This type of damage occurs when a catch is made. Some components may be used again, but the cable cannot. Galvanized aircraft cable is strong because it is made with hard steel wire. A cutter specifically designed for cutting galvanized aircraft cable needs to be used with this product. Diagonal cutters, fencing pliers, lineman's pliers, leatherman tools, and other similar items will not provide the needed results. The overall length of the cable used in a cable restraint varies between 48 and 72 inches. To restrain an animal humanely, we must ensure the captured animal does not become entangled in rooted vegetation or objects like fences. Overall length should be only that which can be securely anchored and create the appropriate loop for the target animal. Anything longer will only increase the potential for injury. Several components are attached to the cable to create a cable restraint. Some of these components may be required by local regulations. Starting at the anchoring end, we will need a swivel attachment. This serves two purposes: to adequately attach an anchoring system like a re-rod or earth anchor, and to be a swivel so the restrained animal can move about without the cable interfering or binding and causing the injury. The swivel attachment will be secured to the cable with an aluminum ferrule. All aluminum ferrules are set on the cable with a swagger designed for this specific purpose. Moving our way to the loop end, we may include a small aluminum stop that can be used as a maximum loop stop. This stop prevents the loop from becoming larger than as defined measurement, say 12 inches. An inline swivel may be incorporated to a cable restraint. This device may also serve as a maximum loop stop. Multiple swivels in a restraining system have great benefit in humanely restraining an animal. The next component will be a loop support collar. These are generally matched to the size of the cable and the size of the support wire used to suspend the loop above the trail. Moving on towards the end, we may include a small aluminum stop that can be used as a minimum loop stop. This stop prevents the loop from closing smaller than a defined measurement, say 3 inches. Like the maximum loop stop, both serve to reduce the potential for restraining non-targeted animals. Loop stops specifying a certain measurement are calculated and measured on the flat piece of cable during assembly. As we get to the end of the cable, we will see 3 components that will finally create the loop. The cable will pass through an S-hook that serves as a breakaway device and is attached to the lock. The S-hook is created to fail at a desired weight so that the larger, non-targeted animal will self-release with no part of the cable restraint attached to its body. The animal exerts enough pressure to open either end of the S-hook, causing the loop to disassemble. S-hooks vary in weight rating, and requirements may exist for a minimum or maximum rating. Cable restraint locks are manufactured from one piece of metal, and the holes through which the cable passes are matched to its diameter. This ensures the lock slides freely back and forth on the cable. The cable restraint is finished with an aluminum ferrule to keep the moving components on the cable. Cable restraints are manufactured with new materials and may shine or hold machine oils and odors that are not common in the field. Cable restraints can be boiled for an hour in a combination of 1/2 cup baking soda per gallon of water. This process removes the odors, oils, and shiny finish from the metal parts. Once complete, the cable restraints should be stored in a clean container until used. Cable restraints are anchored adjacent to the trail being traveled by the target species. A loop support system is fashioned to suspend a correctly sized loop at the right height in the center of the trail. The target species travels the trail and unsuspectedly places its head through the loop, causing the loop to encirculate the neck. As the animal pulls, the loop becomes smaller. With no effort, the loop size relaxes slightly and humanely restrains the animal. We will demonstrate more in our next video, cable restraint set targeting fox and coyote. Thanks for watching this video on cable restraints. Please be sure to check out the BMPs and other trapping resources on the Association of Fish and Wildlife Agencies website.